Welcome students, I welcome you all to my class. Today's class is Newton's laws of motion. Now, after the completion of this class, you will be able to understand Newton's laws, get knowledge about the day-to-day happenings happen because of Newton's laws and invoke skills in developing new tools based on Newton's laws. Do you know who is this? Yes, this is Isaac Newton, who is behind Newton's law, and he is supposed to be the father of physics. Now, do you know this person? If we tell us about laws of motion, we should not forget this man who is Galileo Galilei, who only first told about the laws of motion, and he is also known as father of physics. In the previous class, you studied about inertia. You know what is inertia? Inertia is the inability of a body to change its state of rest or of uniform motion or direction, is it not? So we can get the Newton's first law from law of inertia. What is Newton's first law? Every body continues to be in its state of rest or uniform motion along a straight line unless it is acted upon by some external forces. So it gives the definition of force as well as inertia. And as it is derived from inertia, it is also known as law of inertia.
Hey Kala, what are you doing here?
I'm just wondering why these books on the table are not moved.
Oh, you see, they have no legs to move. Haha.
But the table and chair have 4 legs. They are not moving.
Ha. You know, our teacher taught us inertia.
Yes, inertia is the inability of a body to change its state of rest or uniform motion or direction. Right?
Yeah, but when we take them, they will move. Huh?
Yes.
What will you do to take them?
Apply force?
Yes, you are right. So Isaac Newton made this into a statement.
Is it?
That means we do things like scientists, yeah?
Haha. You know
Do you know?
Newton's statement? No.
Everybody in this universe will be in a state of rest or uniform motion unless otherwise they are compelled to move by any external forces.
Oh, it's called Newton's law, isn't it?
Yes, but it is Newton's first law of motion.
It resembles definition of inertia, right?
Yes, that's why it is also called law of inertia.
Thank you, Raj. Now I am somewhat thorough with Newton's first law of motion. Thank you very much.
Have you listened to this? Are you thorough with Newton's first law of motion? Okay, I'll be asking some questions about Newton's first law of motion. See, the forces acting on a body at rest are equal. You can say true or false. Forces acting on a body at rest are equal. The answer is yes, true. Okay, because if a body is at rest, if there may be forces or no forces, if there is forces, those forces will be equal for the body to be at rest. Now the next question is, if a moving object is to be stopped, force should be applied on it. Is it right or wrong? Yes, it is also true. If you want to stop a moving object, we have to apply some force on it. Okay, there is a total force acting on the satellite which revolves around the earth. Is it correct? There is a total force acting on the satellite which revolves around the earth. It is true because of some forces only the satellite is revolving around us. Now the fourth question is, there will be no external force is acting on an object which is at rest. This is just the ulta of the first question. So what will be the answer for this? Yes, it is false. Even if the body is at rest, there may be some external forces acting. Okay. Now look at this. If you are asked to move the big stone, see there is a collection of stones, big stones and small pieces of stones. If you are asked to move the stones, either the big stone or the small pieces of stones, which one will you do? Yes, it is not easy for you to move the big stone, is it not? But you can easily move the small stones at least by taking some handful of it from there, is it not? But it is very difficult for you to move the big stone. Why? Because the big stone has more mass. Okay. And see, if these two objects are moving and if you are asked to stop these objects, will you do it? Yes. The moving objects can be stopped by applying a force which is just equal to the force due to the moment. Based on this, we are formulating Newton's second law. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of force. This is called Newton's second law. Okay, therefore F is equal to ma. Let us see how does this come. Where m is mass and a is acceleration. Now change in momentum. You know, momentum is a quantity. I will explain what is momentum. Momentum is a quantity which is the product of mass and velocity. Each moving objects will possess momentum. Therefore, change in momentum means final momentum minus initial momentum. So, mv minus mu. Rate of change of momentum means that divided by t. Therefore, mv minus mu divided by t equal to m into v minus u by t. We can take this m commonly out. Therefore, we will get v minus u divided by t. What is v minus u by t? Rate of change of velocity. It is acceleration. Therefore, F is equal to ma. We arrived at Newton's second law. Now see, these are all the examples of Newton's second law. Now we came across a word of momentum. We can see something more about momentum. The impact of force is more if the velocity and the mass of the body is more. So, to quantify the impact of force exactly, we are introducing a new quantity called linear momentum. The linear momentum measures the impact of a force on a body. What is linear momentum? Already I told you, the product of mass and velocity of a moving body gives the magnitude of linear momentum. It acts in the direction of the velocity of the object. And linear momentum is a vector quantity. Because velocity is a vector quantity, so linear momentum will also be a vector quantity. So linear momentum equal to mass into velocity. Linear momentum is given with the notation P. Therefore, P equal to m into v. This momentum helps to measure the magnitude of a force, as I told already. According to Newton's second law, if we have to move a heavier object or an object with more velocity, more should be the force applied. Likewise, in order to stop an object from motion, heavier body and speedy body need more force to be stopped. Now tell me, which one has more momentum and more force is to be applied on it to stop? Here, a deer and an elephant are there. Which one has more momentum? Yes, the elephant has more momentum because elephant has more mass as momentum is the product of mass and velocity, if it is moving, we can multiply mass with this. So it has more momentum than the deer. Now, which one has more momentum? Yes, as the car is bigger in size, it has more momentum. So we need more force to stop a car from external, from outside. Now, which one has more momentum among these? You may think as the ball is big, this may have more momentum. But it is not so. The cricket ball, even though it is small in size, it has more mass. This football has less mass than cricket ball. So cricket ball has more momentum and we need to apply more force to stop the cricket ball. Now some examples, some questions from this Newton's second law. If a body of mass 10 kg is applied with an acceleration of, what is the value? 15 meter per second square. What is the value of the force on that body? So we are given with the masses 10 kg and acceleration 15 meter per second square. We are asked to find force. What will you do? Equation F is equal to m into A. Just substitute here. M is 10 kg, A is 15. So we will get 10 into 15, 150 Newton. Next question. In a cricket match, a bowler bowls the ball with a velocity of 140 meter per second square. The batsman applied a force in a duration of 0.1 second. If the ball gets accelerated with a velocity of 150 meter per second, what is the value of the force applied on it? Understand the question? In a cricket match, a bowler bowls with a certain speed and the batsman applied a force on it for a small duration and the ball moves with another velocity. Now we are asked to find the force applied on the ball because of the hit of the batsman. You know, mass of the ball is 150 gram, which is given here, and initial velocity is given as u is equal to 140 meter per second, v is equal to 150 meter per second, time is given, mass is given, and we are asked to find, see, mass is 150 gram. So we have to convert this mass into kilogram. As we are using SI system, we have to convert 150 gram into kilogram. So it is 1.5 kg. F is question mark. Now equation F is equal to m into v minus u by t. We have to substitute all the quantities. M is 0.15, v is 150, u is 140, divided by t is 0.1. So we get this term, this bracket is minimized to 10, divided by 0.1. We will get 15 Newton. Okay. Now next question. A force of 25 Newton acts on a body of mass 5 kg, which is at rest and make it to move. What is the acceleration produced on the body because of the force? See, a force of 25 Newton is acting on a body. F is given, M is given. You are asked to find A. So we know F is equal to ma from Newton's second law of motion. Just substitute it and find the value of A. Okay, A is given as 5 meter per second square. Now we are studying Newton's third law of motion. Everyone knows Newton's third law of motion. For every action there is an equal and opposite reaction. The action and reaction always act on two different bodies. Now if a body A applies a force Fa on a body B, then the body B reacts with the force Fb on the body A, which is equal to Fa in magnitude but opposite in direction. Therefore, Fb equal to minus Fa. This is Newton's third law. Now some examples we can see. When birds fly, they push the air downwards with their wings and the air pushes the birds upward. Is it not? See, the action given by the wing is the force, that is action force, and the air makes it move up, that is the reaction force. Likewise, when a person swims, he pushes the water using his hands backward, that is action, and the water pushes him towards a front, that is in the forward direction, that is reaction. See, when you fire a bullet, the gun recoils backward and the bullet is moving forward. And the gun equalizes this forward motion by moving backward. This is action. Bullet moves forward, gun moves backward. See what happens. When the gun moves forward, bullet moves forward, gun moves backward. When we jump from the boat will be moving backward. The action is that we step on the boat to jump. So the boat moves backward. When the air from the balloon moves downward, balloon moves upward.